And in the packet, you had to go towards the beginning of the packet. You had to flip back over there. It's 1.9. And you can see that there's a line, there's a right triangle, and you were looking for the hypotenuse. Basically, that's what you're doing, is the hypotenuse of a right triangle. And this all comes from the formula that we all are very familiar with, which is the a squared plus b squared. We could also think of it as x squared plus y squared is equal to maybe r squared. In your trig class, you'll notice that r will be called the radius of a circle. So in your trig class, you're going to look at something similar to this unit circle. Distance is 1, so this will be 1 to begin with. So x squared plus y squared equals 1, and it's centered at the origin. Centered at the origin. So if you looked at this right here, that whole length right there, that could be your x, and the distance right here could be your y, and this distance right here would be your r. That's all it's saying. I need to shut my window. The garbage man is coming again. So one idea, instead of using the formula, here's the formula. You take the difference of the x's and you square it. You take the difference of the y's, square it, add it together, square root. So instead of doing the formula, I could remember this, and I'm just counting. This is your x right here. Counting, let's see, there's 1. The distance is 1. This one here's 1. And then 1, 2. The distance right here is 2. So your x squared and then y squared. Let's make it d squared instead of r. We'll make this d instead. So that'd be 1 squared plus 2 squared is equal to that. And then you got 5 is equal to that. And then you take the square root of both sides. Distance for you guys will never be negative. When you take the square root of both sides, you do have 2 results. I'll just remind you, when you take the square root of d squared, think of it as like a polynomial. Like how many zeros do we have? Polynomial. Instead of this being, let's say it's x squared, you have 2 solutions. So you go plus or minus square root of 5. But then we discount the negative because distance isn't negative for us. So root 5. So you can use the formula. If you use the formula, you would go 3 subtract 1. Well, there's 2. And then 2 subtract 1, and there's 1. So I don't care how you do it. You know, on the final exam, there's probably going to be only one problem because it's not hard. One problem in the final exam, do it any way you want. Okay, find the distance here. This is way too easy. You just count. Because the vertical line and horizontal line, something's going to be 0. So all you do is just count. I'm just going to count from here to there. Let's see, 1, 2, 3. The distance, which is right there, equals 3. There was no formula at all. No formula. Okay, here's my J and there's my K. I'll do the formula this time. Instead of counting, I'll just do the formula. Let's see, the J would be -3, -4, -5. So that would be -5, comma 4. And that's 3, 2. And you're looking how far it is over there. So D is equal to the difference of the x's squared, and the same thing for the y's. So who's first? Just because I read from left to right, here's first. And over here is second. Okay, so 3 subtract -5. So 3 subtract -5. Three subtract -5 squared, and then 2 subtract 4. It's possible that the homework problem might say decimal approximation. You just use your calculator. It's likely that if you could pull out a perfect square out of this, that you'd simplify it. So on the multiple choice versions of any quiz or exam, you look at the answer. If it doesn't look like that, it might be because there's a perfect square and you have to pull it out. I don't know if there's a perfect square, like 4. Does 4 go into 68? Actually, it does. Yeah, 4 does go. 4 goes to 64 plus 4 more. So 68 divided by 4. Yeah, 17. So this is the same here as 2 root 17. That will be the best answer right there. That'll be the answer that you would see in the back of the book and your multiple choice test. Not going to get any harder than that. Oh, yes, it will. Fractions. If you had fractions, then you got to deal with the subtracting and adding. You can't count. You'll just have to do the formula, the subtracting, adding fractions. So common denominator, things like that. That would probably be the hardest. Speaking of fractions, then we got this midpoint formula. So if you got a point here and a point there, what's the point halfway in between? That's where the C is halfway in between. And so you just take the x's and the y's, you take the x's, add them together, take the average of the x's is what it's doing, and the average of the y's. And again, it's easy unless you have fractions, and then it becomes an arithmetic problem. All right, let's see. Halfway in between. Well, there's halfway in between right there. It looks like 3/2, comma 2. It looks like that, but I'm going to double check it with x of 1 plus x of 2. Who's x of 1? I'm reading from left to right. I see q is first. So I'll say that it doesn't, if you're adding them together, it doesn't matter. All right, so you got 1 plus 2 over 2, and you've got 1 plus 3 over 2. Sure enough, it did look like what I'm going to get right here. 3/2, comma 2. Yep, sure, check. I think my recorded video on this is 10 minutes. That I have. Gosh, I don't know if I've uploaded that for you guys. Well, you'll have it today because it's live. So if you go back and listen to the recording today or watch it, you can fast forward through all this garbage stuff that I'm just talking too much. Rochelle is saying, "Oh my gosh, quit talking. Get to the end so I can go and have breakfast. Halfway point. Yeah, well, looks like right about there-ish, wherever there-ish is. Okay, let's see. 6 and 3. So I go 3 plus 6 divided by 2 is 9/2. That's the y. The x is exactly the same. So the midpoint looks like the x is 2 and the y is 9/2. X is 2 and y is 9/2. Back to the J and K. I think this was -5, comma 4. I've talked about the fractions, but I've not done any. I probably ought to take a look at your textbook and see if they've given you any. Let's see if there's anything else in here. Yep. So. Oh, these are interesting. Uh, 19 through 24 are very easy. 25 is harder. I'll do one of those. I'll do 25. And these are weird. Well, what's weird about it is the root thing. So I'll do 25 and 27. 25 and 27 out of your textbook. Okay, so common denominator is already there. That's, see, not even that hard because I've already given you ones with a common denominator. Negative 12 over 2. It's too easy. If I were going to create one for the multiple choice test, I'd create it harder. I'd have like maybe -5/3. That's more interesting to me. Anyway, negative 6. Negative 12 over 2 is -6. -6 over 2 is -3. I see it as -3, comma 2. Easy. Okay. 3 subtract 11. That's -8, -4. -4 divided by 2 is -2. So if I did that all mental arithmetic, if I probably made a mistake. Try it again. -12 over 2, -6. -3. Okay, that's good. negative 8 divided by 2 is negative 4 divided by 2. No, I think I did it right. So not hard. Well, that was number 25. Okay, number 27. Let's see. Eight, and okay, so you got okay, 8 subtract. So, all right, fine. You want to see the setup. I know a couple of you do, no problem. And then you've got 3 root 5 subtract 7 root 5 all divided by 2. Okay, that's 2 over 2 is 1. Now, in your root journey, I don't think we've done much there in the algebra part of it. So last semester, even the semester before that, you're beginning algebra basically. These are like things, I can add those together. You just take the 3 and subtract the 7, getting negative 4, and you carry the root 5 along. So that's negative 4 root 5. This is negative 4 root 5 all over 2 still. And then finally, that reduces, and you got 1 comma 2 into the 4's 2. So negative 2 root 5. Now, the only other thing in this 1.9, even though I called this midpoint formula and distance formula only, there's one little piece at the end. I think I've given you a couple problems to consider. It's equation of a circle. So I've given you a few small ones. Not a bad thing to look at. Your geometry class is coming, or your trigonometry class is coming. So you'll probably forget most of this 5 minutes worth, and you're going to get a whole lot of it. But in terms of trig, sine, cosine, tangent, you might have heard that somewhere, sine, cosine. Well, anyway, you'll see circles again. There's if you ever taken a formal geometry class, we don't offer a formal geometry math class. We just don't do that. Supposedly before I came, they did a long time ago. So anyway, we don't have a formal. What we do now, though, anybody taken our math 156 here before this class, like last semester, 156? Anybody do that? The people that have, I don't know, Bonnie, do you see anybody saying yes?
I don't see, I'm not looking at the gallery.
Interesting, I would be, I don't know. People are willing to share in the chat room. I can read it later. What course did you take before this? What was your course before taking Math 25? If you're willing to share that, I'll read it. Other people are going to see it too. You can do a private chat. Why don't you do that? Do a private chat with Jeff and just say, here's my previous course that I had, because that'll tell me whether or not you had, I'll call it geometry, ellipses, parabolas. Well, everybody does parabolas. Ellipses, hyperbolas, circles. Those are called conics. Yeah, so do a private chat if you want. I'll only see it. Bonnie might too, but no student will. And that way I can get a sense to this class. For everybody today, you're going to look at the formula of a circle centered at H and K is the center. H and K, doesn't that sound familiar? Where did we hear the H and K before? Anybody remember that? H and K. Like, what was the H and K about in a previous? We have done that in this semester. Oh, you guys have forgotten already. That's not good. Coming up in the final exam, you're going to have to remember.
Didn't that have
But
something
H
to
and
do
K.
with?
Bonnie, remind me where the H and K. Remind everybody.
It's sounding like a vertex of
Yep.
of a certain type of what would you call it? Graph. A certain type of graph we've been looking at this semester with a sort of a dome shape or a valley shape.
Parabola.
Parabola.
There you go. Yeah, the vertex. She's right. It is. You guys did that. You guys did parabolas again. So the H and K symbol is now for the center of the circle. That's what it's representing. And the R is for the radius.
And this stuff does come back in Math 1B, you guys, just in case you're curious. We had a whole
My
section
volume
on.
is super. Yeah, hold on a second, Bonnie. I got to figure out how to get my volume louder, and I've got my poo. When I plug in my, okay, I'm going to unplug my monitor because then I'll get my speaker on my computer. For some reason, my, okay, speak up, Bonnie. Say it again.
Can you hear me now? Can you hear me? Can you hear me? Sound check.
Better.
Okay. Yeah, I was
Okay.
just saying that in Math 1B, there's a whole section on conics, and I think we get to do some calculus with them, or maybe that comes back later. I don't know. It's all kind of a blur, but this stuff definitely comes back. And we learned about hyperbolas and parabolas, and I don't even think I knew what a hyperbola was. So some new stuff.
You're right. You do that, and you might even come up with it, what my remembrance of, say, the ellipse and there's something called the focus or the foci, which if there's two of them, that's the plural foci. There's a focus that you'll probably deal with in your 1B, Bonnie, if you haven't already.
Definitely. Yep, we did that. And ellipses, circles.
Yep. And then, yeah, you'll do the calculus, like you say. You probably do things like derivatives on it. And I don't know if you'll do integrals, areas, but so Bonnie's saying it will come again. For you guys, you're going to see the circle in Math 58 again. I don't believe we ever see conics in 1A. I never do it. So it'll be a long window of time before you see it again in 1B, like Bonnie's talking about.
Well, and I saw somebody had an interesting comment that, there's certain chapters that get cut out due to the fires. And I've definitely had that experience too, where you get to somewhere and they're like, you should have seen this already in pre-calculus. And it's like, yeah, well, not a perfect world.
No, so, it's not.
Yeah.
No,
well, hopefully most of the teachers, I think, are being fairly understanding when it comes to, giving a little bit of review along with stuff that you should have seen already, because sometimes you just didn't get to it in the first place, or maybe you did, but it's been a long time and you've kind of forgotten. So I think the teachers are being pretty understanding about all that. So
I honestly believe that once you get past, all of you, including you guys, once you get past your intermediate algebra and you know that you're on a journey to calculus, I believe majority, I would like to think all of you have the sense of you need to know this, and you can do this. You're the type of caliber of a student that if you put your mind to it, you will do the research, you'll do what's necessary to keep up with the class or ask the questions. You will. So this has been a great class in terms of your choice of a Math 25. See, I have more time to go like this in a class like this rather than a Math 27. You've chosen well, and I think the grades are reflecting that. Even though multiple choice tests, 24 hours, that's a lot of time, tends to be easier. And I don't have any way of really controlling the cheating if it is happening out there. But I think all of you realize that you can do this. And when Bonnie says, it's been a long time since I've seen conics, Bonnie would figure it out, or has figured it out. She's Googled it, she's asked questions, and it's harder, but it's not impossible. So for what you guys are doing, very simple, couple problems. One is very, very easy. Write the standard form of the equation. So here's the standard form of the equation. Write it, and they're giving you the center. So it's basically plug and chug. So it's will look like this, x. Now the thing that you need to remember is those subtraction signs are always there. I tend, like over here, I tend to include that subtraction and throw that next to it. That's what I do, so I don't screw up, signs. So there's that subtraction sign there, and then, oh, there's the H. This is called H, and this is called K. So H is 1. Got to put the square. And then you go Y. Okay, there's the subtraction sign right there. And I stick the negative and the 5 right next to it. The negative as well, because I'll change that in a second. And the radius is 4. So you got to go 4 and you square that as well. It feels like a squared plus b squared is equal to c squared somehow. Don't expand this. I don't think the standard form. Good question. Hold on a second. Because this is one version of the standard form here. If you have to expand that, it's not an impossible thing. I'll tell you what to avoid in terms of the mistake. Let's say I leave it right now this way. They will make it 16. The question is this, like written out? Could be. The mistake that happens for all of us, even probably Bonnie, if I don't say it, she might maybe forget. Y squared plus 25, yeah, that's not what this is. This is not square each one of those individually. So yeah, that's right. Write it down twice. Someone had to say it. So we're all going to make that mistake probably until someone says, don't do that.
I think that was what we had a bet on earlier in the semester, Jeff, of whether somebody was going to be distributing the squared sign on one of the exams.
Yeah. And, that's a good question. And I'm trying to think of where that was. If it was it might've been exam 2. Yeah, it would not have been exam 3.
Yeah,
so,
I think it was exam 2.
Okay, I'm going to go back. I'm going to write myself. Hey, stick around after class, Bonnie. You and I will take a look at it. And we'll go back and look at the results and see if anybody made that mistake and see who won the bet.
You can only distribute that squared if it's multiplication inside, you guys.
That is correct. So if you had, like, say 5y rather than 5 plus y.
Yeah.
Yeah, that's what Bonnie's saying. This one here, you can go 5 squared y squared. Here, you cannot do 5 squared plus y squared. You just can't do that. So if it's a monomial, basically, if it's a monomial, you can put the powers of 2 on everything. Otherwise, you got to write it down twice in FOIL. So check the back of the book if that's, or your answer choices for multiple choice, if they don't look like that, but they've got a bunch of stuff like x squareds and x's and numbers, and they've expanded it and collected like terms. This one here works backwards. They want to know what the vertex, I said vertex, the center. So H comma K. Now there is no H here, so that's got to be 0. And here's the common mistake you tend to probably forgotten, and we'll make, and on the multiple choice, it's going to be here. I'll write the mistake down. I wrote, write yourself a note. This is a mistake, because that choice will be on the multiple choice part of the exam, because someone's going to forget. Yeah, that's not right, because there's got to be a subtraction sign here. It's like take the opposite. You guys remember the transformations? That's the same idea, right? You look inside the argument and you always take the opposite in terms of the direction you go. So similar transformations. So this is your center. And then radius. Radius is not 25. That'll be a choice on the test. Radius is 25. No, it's the square root of that. So it'll be 5. Radius is 5. And if I want to do a sketch of the graph, you know, like this, 0, comma, -3. So let's see. Okay, there's the center. And if the radius is 5, you're going to count 5 up, 5 this way, 5 this way, 5 that way, and put dots there is what I'm going to do. So count up 1, 2, 3, 4, 5. That distance or radius is 5. You go like 1, 2, 3, 4, 5. I guess freehanding is awful for me. Yeah, that looks pretty crummy, but you could get a compass. Anyway, hard to do a freehand circle. That's pretty good, but trying to connect the dots is pretty awful. Okay, now the domain, this is not a function. You guys know that too, not a function, but the domain of the picture, domain right here, it's from left to right. So from left to right, yeah, domain is from, looks like -5 to 5. Domain, D for domain, and you would include it, so it's bracket, and it's the X. So it's negative, that's positive, sorry, 5, -5. And then the range, okay, now it's not -5 to 5, it's, let's see, 1, okay, that's 2. That's -3. So 4, 5, 6, 7, 8. So -8 to 2. -8, that's the Y's. I'm gonna put it interval. You could do interval. And if it was set building notation, don't forget your little squigglies. Oh, can't squiggly. There would be Y such that, and you could say it's real numbers like this, or just put this in, -8 less than or equal. I'm squeezing it in. Sorry. Squiggle. Yeah, that would be formal set building notation. Well, there you go. I took longer than a half hour, didn't I? But